Our story begins with the egg test. This appeared on Twitter a little while ago, and it basically involves somebody in a white coat looking suspiciously medical, dropping 2 eggs, one onto an insole and one onto a gel insole, which is a control group. And of course the one dropped on the gel insole breaks and the one dropped on the other insole does not. Now, leaving alone the questions about relevance to clinical practice, because we don't generally use insoles to protect our falling ovulations, there was a question raised over the validity of this test and whether or not it was appropriately carried out. This question was raised by Ian Griffiths, sports podiatrist, blogger, podiatrist and pedant of this parish, who called bullshit on it, strong words indeed, and zoomed in and slow-moed to try to make his point. Now, in the slow-mo close-up, you can see that the egg appears to fall more onto the outside of the insole than the centre, but there is a little bit of a glitch, which I guess is what Ian was questioning in terms of the validity of this test. A chap whose hashtag is that he is the CEO of Enerta fired back on Twitter, saying that the test was valid, the video is real, he wasn't a doctor, but hopefully we didn't claim that. The white coat is just a sciencey prop. I've done it many times myself in the kitchen. The long winter nights must just fly past in that house. And quite reasonably saying, well, why maybe try it for yourself?
Right then, so this is the home version of the insole test. You'll have seen the one on Twitter where somebody drops an egg and it bounces off there, but it breaks on gel pads, so I wanted to do it for myself. And for Ian, happy birthday, mate. So, just for reference, these caliper at 6mm thick, 9mm thick, and this is a pair of size 3s. I ordered these off the internet, and just for reference I'm going to be testing it against a piece of bog standard 6mm pour-on, so there's a 3mm advantage to that. The eggs we are using are finest quality basics Tesco's eggs. Let's see how we do.
No, I'm not wearing a white coat, it's not quite as sciencey, just try and move on from that, okay?
So we're going to start with a nice low drop and work our way up. So we will start, the chap did it from eye level to down there in the video. We're going to start from a bit lower. We're going to start from 18 inches up and we'll go fat end of the egg down. 3, 2, 1. That worked. We'll need a rubbish bag. So test number 1 from 18 inches onto the insole, worked. 18 inches onto the pour-on, same thing, flat end down, also worked. 20 inches. 20 inches on the insoles, worked. 20 inches on the pour-on, also worked. Yep. 22 inches onto the pour-on, also worked. 24 inches onto the insoles. We're still not quite up to the test level that they used. Ooh. Ah, no, we have a breakage. 24 inches onto the insoles was a fail. Just going to repeat that one though, because of course it could have just been a bad egg. So 24 inches. Ah, second time it was fine. Yeah. This was a terrible idea. 24 inches onto the pour-on. So remember, we've had one fail at 24 inches on the insole. No, that's good. Okay, now we're going up to 26 inches onto the insoles. That's good. And 26 inches onto the pour-on. Nearly dropped it, which is kind of the point. Yeah, no problem at all. 28 inches onto the insoles. Oh, another crack. Yeah, so 28 inches as a fail. Secondary test, because again, might have been a bad egg. Should better clean the. Could be a confounding factor if the humpty dumpty experiment was wrong. So this was 28 inches onto the insole. I'm trying to aim it so it always falls in the same spot. Ah, second fail, but that was a bad drop. Third test, 28 inches. Now, it did crack on the rebound, but I think we'll give that one the benefit of the doubt, just about. 28 inches onto the pour-on. Absolutely fine. So far we've had 2 failures at 28 inches on the insoles, 1 success. The pour-on has yet to fail to protect the ground from eggs. You need no longer fear the egg menace. 30 inches, so we're heading towards eye level here. Yeah, that was a good bounce. 30 inches with pour-on. I need to wash my hands, they're getting sticky. Yeah, absolutely fine. 32 inches. That was good. Oh God, except we got egg on the deck again. Your mother is not going to be amused.
No, she won't.
So that was 32 inches onto the pour-on. Yeah, that was good. Bounced onto the table and broke, but that was okay. Okay, so we've only got 2 eggs left. So we're going to go straight up to eye level, which is about 39 inches. So this is a little further than in the test. First one onto the insole, 37 inches we'll call that. Ready? Yeah, that's an emphatic, solid, crunchy fail. I'm not expecting this to be any different. Did I say 37 or 39?
37.
I said 37. Okay. This is my lovely research assistant. Onto the pour-on. Pour-on survived.
So what does that mean in real terms? Not very much at all. It wasn't my idea to use eggs to represent the human body and illustrate impact. But what we do see consistently with all of those is that when the egg hit the D30 insole, it bounced, whereas when the egg hit the pour-on, it didn't. It just sort of splatted. It just went dead and stopped. And that comes into the difference between energy return and shock absorption. The Enitor insoles claim on the packaging that they are excellent for both energy return and shock absorption, which is kind of not internally consistent because energy return is shock. Something hits a surface, the energy goes into the surface, there is an equal and opposite reaction from that surface back into the thing that's just hit it. That's the energy return. So if it's absorbing the shock, absorbing the energy, it's not returning it. It cannot both absorb and return energy. D30 is marketed as having the properties of a non-Newtonian polymer. What that means is it's a material which has different properties depending on how quickly you interact with it.
Tell everyone at home what a non-Newtonian polymer is, please.
It snaps in half when we do it quickly and it comes string when we do it slowly.
Would you like to show us?
Yes. Okay.
It's snapped in half.
Yes.
So does it always snap in half
On
then?
there. No, not unless we do it fast.
Okay, so show us what happens if we do it
On
slowly.
there.
Oh, I see. So it's going like string. And why is it that it does that again?
Because it's on Newtonian polymer.
Oh, okay.
When you interact with it quickly, it will be harder and more brittle, and when you interact with it slowly, it will be softer and more malleable. Now, I remain to be convinced that the material in those insoles is a non-Newtonian polymer, or behaves like one. But if we take that as true for a second, then what we see with the eggs makes perfect sense. That an egg hitting an insole is quite a rapid deformation. It's a rapid effort to deform the material. So it would make sense for that insole, that material, to become stiffer, to become harder, to return that energy more, which means the egg will bounce higher. So in terms of energy return, yes. But in terms of shock absorption, no, that's the opposite of shock absorption. Obviously, there's always a little bit of this sort of thing in marketing, that we use buzz phrases that sound appropriate. But when something is being marketed as having these properties, it is a good idea to actually think about it for ourselves and to try and work out how it all works. So, hope you enjoyed that. Happy whatever the day of the year it is.